Okay, let's talk about productivity. Okay. When you talk about productivity, the word or the term competitiveness goes with it. Okay, because productivity determines how competitive you are in the marketplace. So the definition of competitiveness would be degree to which an organization can produce goods and services that meet the test of the market. Now, productive is simply a ratio of output to input. Okay? And what is output? Output is what you produce, right? Like sales made, products produced, customer served, mails delivered, call answered, all of them are form of output. Input is what goes in to produce the output, like labor, investment, storage area, materials, energy, and such. There are different measures of productivity. The first one is single factor productivity, okay, where output is divided by labor. So you can determine how many pieces of or how many units of output you are producing per unit of labor. Okay. Similarly, you could have output divided by materials, output divided by capital, where you will find how many units you are producing per unit of money, which would be per dollar. Okay. As you can see, in measures of productivity, output always sits on the top. Okay. When you use one form of input, then you get single factor productivity. Multi-factor productivity, as the term implies, you can figure that when output is divided by labor cost, material cost, overhead cost, then you have a multi-factor productivity. Similarly, you could have labor, energy, capital. You can have a different set of input, okay, depending on the circumstance or what you are trying to figure out. Okay. Total factor productivity, as the name implies, it considers everything together. That means goods and services produced, the total goods and services that is, and the total inputs used to produce them. Okay. That is total factor productivity. Now, here is an example. Okay, it's a problem. The problem states that Osborne Industries is compiling the monthly productivity report for its board of directors. From the following data, calculate number one, labor productivity. Okay, so it's a single factor productivity. Number two, machine productivity. That is also a single factor productivity. And the multi-factor productivity of dollars spent on labor, machine, materials, and energy. Okay. So as you can see, all four of them are mentioned. So it is actually, you can also say it's a total factor productivity that they want you to calculate. The average labor rate is $15 per hour, and the average machine usage rate is $10 per hour. Okay. So the total units produced here is 100,000. Labor hours used to produce them is 10,000 hours. Machine hours used to produce them is 5,000. Materials that goes in producing those units cost $35,000, and energy that goes in terms of input to produce those units is costs $15,000. Okay. Now the first question asks you to calculate labor productivity. Remember the formulas in the previous slide, that single factor productivity is output on the top and that single factor at the bottom. Since it's labor productivity, so we put, okay, output divided by labor hours, okay, which is 100,000, as you can see. Okay, units produced is 100,000 and labor hours 10,000. So 100,000 divided by 10,000 gives you 10. So you get 10 units per hour. That's your labor productivity. Okay. Now machine productivity, which is the number 2 question that they ask, the machine productivity. So machine productivity would be output divided by machine hours, and as you can see, there are 5,000 machine hours. 100,000 units being produced by 5,000 machine hours. So 100,000 divided by 5,000 gives you 20 units per hour. Okay. This was 10 units per hour, that's labor hour, and this is 20 units per hour, this is machine hour though. So be careful about making that distinction. Multi-factor productivity or total factor productivity in this case would be output divided by labor cost, machine cost, material cost, and energy cost. Okay. Now notice that we don't have labor cost given. We have labor hours, but we also know that the labor rate is $15 per hour. So labor cost is 10,000 times 15. Okay. Machine hour is given to be 5,000. We don't have a dollar amount. However, we know that the machine usage rate is $10 per hour. So 5,000 times 10 gives us the machine cost. Okay. Then we have material cost and energy cost directly given to us, so we put the 35,000 and 15,000 directly there. Okay. Now, if I did my math right, it should be 100,000 on the top and 250,000 at the bottom. As you carry out the division, you get 0.4. So that would be 0.4 units per dollar spent, which is the third question, the multi-factor productivity of dollars spent on labor, machine, materials, and energy. Okay. So here you have single factor productivity, okay, like labor productivity and machine productivity, and a multi-factor productivity or total productivity in this case is this. That's all about this example. Until next time, I'll see you later.